Hi, so today this will be the function I'm going to show you how to graph and analyze. So to find the degree in a multiplication function like this, you have to add the number of exponents. So 3 plus 2 is 5, which would give you a degree of 5. The number of solutions is the number of degree. So you'll have 5 solutions. So to determine the number of turning points, you take the number of solution in degree and subtract it by 1. So it would be 4 turning points, but it's important to remember that it could be 4 at most, because imaginary solutions might also be present. The leading coefficient in this equation would be 1, because in front of the x, there's no number. The end behavior, since it's an odd positive equation, would be rise to the right and fall to the left, and you can actually see that when we graph it in a moment. To see the y-intercept, you make all the x's zeros, so -2 squared and 1 cubed. So -2 squared is 4 times 1 cubed is 1. So your y-intercept would be 0, 4. Now, in factored form, it's really easy to see the 0 since it's already factored. So x minus 2 equals 0 will give you a 0 of 2, 0, and x plus 1 equals 0 will give you a 0 of -1, 0. So now we can finally graph. So it's important to remember when you're graphing the multiplicities. So since x minus 2 has a multiplicity of 2, which is even, it's going to bounce. And since x plus 1 has a multiplicity of 3, it'll go straight through the axis. So this is what your graph would look like with that bounce at the multiplicity 2. So the domain would be from -infinity to infinity, and the range would also be from -infinity to infinity, because the x and y could be an infinite number of solutions. And also, it's really important, sometimes when you graph, you can put an x at where you would do the multiplicity so you don't forget, because a lot of people tend to forget that. And that's it.